Good morning, everyone. My name is Sunitha, Assistant Professor in Mathematics Department of HNS. Today, I am going to teach vector differentiation. Vector differentiation. What is the scalar? A physical quantity which has magnitude only is called as a scalar. For example, every real number is a scalar. What is the vector? A physical quantity has both magnitude and direction is called as a scalar. For example, velocity. Then scalar and vector point function. Consider a region in three-dimension space to each point p of x comma y comma z. Suppose we associate a unique real number called scalar, say pi. This pi is pi of x comma y comma z is called a scalar point function defined on the region. Similarly, if to each point p of x comma y comma z we associated a unique vector f bar x comma y comma z, then f bar is called a vector point function. Then vector differential operator. The vector differential operator is denoted by del. Vector differential operator is denoted by del. This is read as del and is defined as I into dou by dou x plus a into dou by dou y plus k into dou by dou z. That is, so vector differential operator del equal to I into dou by dou x plus a into dou by dou y plus k into dou by dou z. Now we define the following quantities which involve the above operator. So based on this operator, we define gradient of a scalar point function, divergent of a vector point function, curl of a vector point function. So first one is gradient of a scalar point function. So if pi of x comma y comma z be any scalar, pi is any scalar point function, then the gradient of pi is denoted by grade pi or del pi, defined as del pi equal to, here del equal to I into dou by dou x plus j into dou by dou y plus k into dou by dou z. We are applying scalar point function pi, then del pi equal to I into dou by dou x plus j into dou by dou y plus k into dou by dou z. For example, if f equal to, this is a scalar, x square plus y square plus z square. So we are applying gradient only scalar point function. So f is scalar, then del f equal to, so del f means I into dou pi by dou x plus j into dou pi by dou y plus k into dou pi by dou z. Here function is f, I into dou f by dou x plus j into dou f by dou y plus k into dou f by dou z. So partial differentiation with respect to x, that is 2x, so I into 2x. Partial differentiation with respect to y is 2y, so 2y into j, plus partial differentiation of f with respect to z, z square, that is 2z into k. The operator gradient is always applied on a scalar field and the result will be a vector. So properties of gradient. So if f and g are continuous and differentiable scalar point functions, f and g two scalar point functions, that is continuous and differentiable, then so grade of f plus or minus g equal to grade f plus or minus grade g. Grade f by g equal to g into grade f minus f into grade g by g square. Then third one, grade fg. So f into g into grade f plus f into grade g. Then note point, if pi is any scalar point function or surface, so pi is not vector, any scalar point function or surface, then normal vector along pi is given by del pi or grade pi. So we have to find normal to the pi is del pi or grade pi. and unit normal vector along pi is del pi by mod del pi. So pi is any scalar, then normal to the pi is del pi, and the unit normal vector of pi is del pi by mod del pi. Next, directional derivative. Directional derivative. The directional derivative of scalar point function pi. So pi is scalar point function at point P. In the direction of a vector point function f bar is given by E dot del pi, where E is unit vector along f bar. So f bar is vector. F bar is vector and unit normal vector is a vector by modulus of vector, that is E. So pi is scalar, then del pi, grade pi. So directional derivative equal to E dot del pi at the point P. E is unit normal vector along the vector point function, and del pi is applying a scalar, that is del pi. Then the directional derivative is maximum, note point. The directional derivative is maximum at the point P is del mod del pi at the point P. This is maximum directional derivative value. Then angle between two surfaces. If theta is the angle between the two surfaces pi 1 and pi 2. So pi 1 and pi 2, two surfaces are scalars. Then theta is the angle between the two surfaces. So cos theta equal to del pi 1 dot del pi 2 by mod del pi 1 into mod del pi 2. Normal to the pi 1 del pi 1, normal to the pi 2 del pi 2 by modulus of del pi 1 into modulus of del pi 2. Then angle between two vectors. So a bar and b bar, two vectors. Then cos theta equal to a bar dot b bar by modulus of a bar into b bar. Then problems. Find grade f where f equal to x cube plus y cube plus z cube plus 3xyz. So f is a scalar. Find grade f. So given f equal to scalar x cube plus y cube plus z cube, here z cube missing, plus 3xyz. This is equation 1. We know that grade f or del f equal to grade f or del f equal to I into dou f by dou x plus j into dou f by dou y plus k into dou f by dou z. To find partial differentiations of f with respect to x, y, z. Dou f by dou x, dou f by dou y, and dou f by dou z. Means partially differentiate equation 1 with respect to x, y, z. Here one term is missing. Dou f by dou x equal to 3x square plus, yeah, right only, not missing. With respect to x, partial differentiation with respect to x. So differentiation of x cube 3x square. So y cube is 0, z cube is 0 plus 3xyz means differentiation of with respect to x partially 3yz. After that, partial differentiation of with respect to y. So dou f by dou y equal to, here x cube is constant with respect to y 0. So y cube, derivation of y cube 3y square plus derivation of z cube, z is constant 0 plus dou by dou y of 3xyz means 3xz. Then dou f by dou z, partial differentiation with respect to z. So x and y constants, x cube is 0, y cube is 0. Derivation of z cube partially with respect to z is 3z square plus dou by dou z of 3xyz, 3xy. So grade f equal to, we know that grade f is I into dou f by dou x plus j into dou f by dou y plus k into dou f by dou z. Substitute dou f by dou x, comma dou f by dou y and dou f by dou z in grade f. So grade f equal to I into dou f by dou x equal to 3x square plus 3yz plus j into dou f by dou y equal to 3y square plus 3xz plus k into dou f by dou z equal to 3z square plus 3xy. This is grade f. So f is a scalar, then grade f equal to this one. Next, show that del f of r that equal to f dash of r by r dot r bar, where r bar equal to xi plus yj plus zk. Here r bar is given position vector. So given r bar equal to xi plus yj plus zk, we know that so r equal to mod r bar. So mod r bar means r is a vector. So mod r equal to under root of I coefficient whole square plus j coefficient whole square plus k coefficient whole square. So mod r equal to under root of x square plus y square plus z square. Squaring on both sides. So r square equal to square and root cancel, x square plus y square plus z square. This is equation 1. Here r is the function in xyz. R is the function in xyz. So whenever we are differentiate r, that is not treating constant. So differentiate equation 1 partially with respect to x, both sides, left hand side and right hand side. So r is the function in xyz. So dou by dou x of r square. So x power n form, n into x power n minus 1. Again differentiate r, dou r by dou x. 2r into dou r by dou x, this is left hand side. And right hand side, dou by dou x of x square equal to 2x. So y and z are constant, that is 0. So 2 cancel, we get dou r by dou x equal to x by r. So differentiate equation 1 partially with respect to y. So r is the function in x, y, z. Then differentiate with respect to y, left hand side of r. So x power n form, n into x power n minus 1, 2r. Again differentiate function r, dou r by dou y. And right hand side, x and z constants. The differentiation is 0. So dou by dou y of y square, 2y. So dou r by dou y equal to y by r. Then similarly differentiate with respect to z, dou r by dou z equal to z by r. Now we have to calculate del f of r. So del f of r equal to, del means I into dou by dou x plus a into dou by dou y plus k into dou by dou z into f of r. So we have to take summation of f of r, f of I into dou by dou x into f of r. So summation of I into dou by dou x means sum of these three terms, I into dou by dou x plus j into dou by dou y plus k into dou by dou z. So I will take one term only. Summation of I into dou by dou x, f of r. So I into dou by dou x of f of r, derivation of f of r, f dash of r, and again differentiate. So inner function r. So dou r by dou x. So we know that dou r by dou x equal to x by r. Substitute this. Summation I into f dash of r, dou r by dou x equal to x by r. So all the three terms common to f dash of r. So summation of I into x by r. So this is taking common all the three terms. Summation of I into x by r. R also common to all terms. So taking out f dash of r by r. So summation of x. This is first term. So expanding summation. Second term is yj. This third term is zk. So f dash of r by r, here xi plus yj plus zk equal to r bar. Now we have to prove this. Del f of r equal to f dash of r by r dot r. Del f of r equal to f dash of r by r into r bar. Then the next problem. Prove that del r power n equal to n into r power n minus 2 into r bar. Here r bar is position vector. Let r bar equal to xi plus yj plus zk. We know that r equal to mod r bar. So r equal to mod r bar means under root of I coefficient whole square plus j coefficient whole square plus k coefficient whole square. R square equal to squaring on both sides. Square and root cancel. X square plus y square plus z square. This is equation 1. Differentiate equation 1 partially with respect to x. We have 2r into left hand side. R is the function in x y z. This is not constant. So dou by dou x of x power n form n into x power n minus 1. Again differentiate inner function are dou r by dou x. Right hand side. So derivation of x square is 2x. Y and z are constants. Partial derivative. So this is 0 y and z. So dr by dx equal to x by r. Similarly, dou r by dou y equal to y by r. Dou r by dou z equal to z by r. So del r power n. Del means so I into dou by dou x plus j into dou by dou y plus k into dou by dou z. I will take summation of only single term summation of I into dou by dou x of r power n. This means summation of I into dou by dou x r power n means I into dou by dou x of r power n plus j into dou by dou y of r power n plus k into dou by dou z of r power n. So summation of I, this is dou by dou x of r power n, x power n form, n into x power n minus 1, n into r power n minus n. Again differentiate inner function r, dou r by dou x. But dou r by dou x equal to, we know that in above x by r, x by r. So n into r power n minus 1 by r is taking common all three terms, summation of x into I. Summation xi means, so in dou by dou x term xi, in dou by dou y term yj, in dou by dou z term z. Xi plus yj expanding summation. So xi plus yj plus z. So here r is coming to numerator. So r power minus 1, r power minus 1. Bases are equal. So adding powers r power n minus n into r power n minus 2 into xi plus yj plus zk equal to r bar. Okay. Del r power n equal to n into r power n minus 2 into r bar. Next problem. So find the directional derivative of f. So f is a scalar. Find the directional derivative of f, that is equal to xy plus yz plus zx in the direction of vector. In the direction of vector I plus 2j plus 2k at the point 1 comma 2 comma 0. So here find the directional derivative of f in the direction of vector I plus 2j plus 2k at the point 1 comma 2 comma 0. Here one scalar given and one point also given, one vector also given, but the direction of the vector. So which vector direction they are asking, that vector only we have to find normal, unit normal vector. Okay, given f equal to, this is scalar. So f equal to xy plus yz plus zx. So grade f or del f. So I into dou f by dou x plus j into dou f by dou y plus k into dou f by dou z. So grade f equal to, so dou f by dou x, partial differentiation with respect to x, y plus z plus j into partial differentiation with respect to y plus k into partial differentiation with respect to z. I into y plus z plus z plus x into j plus x plus y into k. So this is grade f or del f. Along with the direction of vector, they are asking which vector direction we have to find that vector unit normal vector. Along with the direction of vector, g bar equal to I plus 2j plus 2k, then unit normal vector e bar equal to, this is z bar. So unit normal vector means vector by modulus of vector, I plus 2j plus 2k by under root of modulus of vector means I coefficient whole square plus j coefficient whole square plus k coefficient whole square. Therefore, the directional derivative of f along the given direction e bar dot del f or grade f. So e bar equal to this one dot del f at 1 comma 2 comma 0. So I dot I 1, the remaining vectors all I dot j 0, I dot k 0. So we are multiplying same vector terms only. I dot I 1, remaining vector I dot j, I dot k is 0. Means 1 into y plus z, y plus z 1 by 3 into. Then j dot j 1, remaining vectors dot product is 0. So 2 into z plus x plus 2 into k dot k, x plus y at the point 1 comma 2 comma 0. So substitute in place of x1, in place of y2, in place of z0, that equal to 10 by 3. Then find the directional derivative of the function f equal to x square minus y square plus 2z square at the point p equal to 1 comma 2 comma 3 in the direction of the line PQ, where q equal to 5 comma 0 comma 4. Here only given function scalar only. Find the directional derivative of the function. So we have to find directional derivative. We want one scalar and one vector. Along the direction of that vector, we have to find unit normal vector. So here only given points p1 comma 2 comma 3 in the direction of the line. This direction of the line, we have to find unit normal vector where q equal to 5 comma 0 comma 4. So the position vector of p and q, here given 2 points p and q. So we have to start origin to, so x-axis origin, so p point and identify the q points. The position vector of p and q with respect to the origin or, so OP and OQ. OP and OQ. Here O is 0, origin means 0 comma 0 comma 0, here P, here Q. So OP vector. So how to calculate OP vector? OP. This is x1, x2, x3, x1, y1, z1. Here P is x2, y2, z2. So 2 points are given. Then to find the vector. So x2 minus x1 into I, y2 minus y1 into j plus z2 minus z1 into k. Here OP vector 1 minus 0 into I 2 minus 0 into j, 2j, 3 minus 0 into k, 3. Then OQ vector, here also same, 5y plus 4k. So our condition is in the direction of the line PQ. So we have to calculate PQ. How to calculate PQ? PQ equal to OQ minus OP. We get PQ. OQ minus OP, we get PQ equal to 4i minus 2j plus k. In the direction of this vector only, we have to calculate normal vector, unit normal vector. Along with PQ direction, unit normal vector E bar equal to PQ by mod PQ, vector by modulus of vector. Modulus of vector means I coefficient whole square plus j coefficient whole square plus k coefficient whole square. Here given scalar f x f equal to x square minus y square plus 2z square. We have to find grade f or del f. Directional derivative is grade f equal to 2xi minus 2yz plus 4zk. So along the line PQ, the directional derivative is e bar dot del f.